class. Today we're going to do a little bit with piecewise functions and show you how they lead into our next topic. So let's try to graph this piecewise function. It just has two pieces and they're pretty simple. So the first piece is just the graph x, and it goes on the portion of the graph wherever x is greater than or equal to 0. So this line just has a slope of 1 and a y-intercept of 0. So it starts here at x equals 0, and it just goes up 1 over 1 and continues in that direction forever. Now the second piece of the graph is just negative x, a line with a slope of -1 and a y-intercept of 0. It's on the left side of the graph. Starts at 0, would be an open circle, but it's filled in by this green one, and it just goes up 1 and to the left one. That has a slope of -1. So if you plug in values, you'll see that this graph kind of reminds us of another graph that you're used to. So let's see. If I plug in the x value of 3, then that's going to go to the top piece of the graph because that 3 is greater than 0. If I use this piece, then I just have a y value of x, which is still just 3. If I plug in -3, then I get this portion of the graph because the x is less than 0. So I just change the sign of my x value and multiply it by a negative. So negative times -3 is just +3. If you look, these points are on the graph 3, 3, and -3, 3. So hopefully this reminds you of the absolute value graph. The absolute value graph, y equals the absolute value of x, can also be written as a piecewise function. It's just a graph that has a V shape. So the x value of the vertex is the corner of the graph, is where the absolute value, the inside of the absolute value equals 0. So let's talk about what this graph would look like here. So now here, my function is the absolute value of x plus 2. So we know that the absolute value of x just is a v, where the corner of the v, or the vertex, is at the origin, at the point 0, 0. Let's see what this plus 2 does to the graph. So if you're ever not sure what a graph looks like, you can just plug in points and see what you get. Super eraser. All right. So now here, let's plug in some points. Let's plug in -3. If I plug -3 into that, I get the absolute value of -3 plus 2. It's supposed to be negative there. So that gives me the absolute value of -3 is 3 plus 2 is 5. So I have the point -3, 5 on my graph. Now let's plug in another point. Let's plug in 0. If I plug in 0, I get the absolute value of 0 plus 2, which is 2. So I have the point 0, 2 on my graph. Now let's plug in, I don't know, 4. If I plug in 4, I get the absolute value of 4 plus 2, which is 6. So the point 4, 6. It's still going to be a V graph. If you're still unsure of what this looks like, just plug in another number. Let's say 2. The absolute value of 2 plus 2 is 4. So I have the point 2, 4. So hopefully this is taking shape to you. If you feel like you need another point, plug in another point. -1, the absolute value of -1 plus 2. The absolute value of -1 is 1 plus 2 is 3. So I have the point -1, 3. Now it should be pretty clear that this is just a V graph that moved a little bit. The origin is no longer where the vertex is. The vertex moved up 2 because of this plus 2. So now let's try another graph. If I try this graph, I have -4 instead. So you may be able to predict what this is going to look like, but if you're not sure, you could always plug in values. Let's try to plug in 5. If I take the absolute value of 5 minus 4, it's going to give me 1. So I have the point 5, 1. Now let's try to plug in a number closer to 0, 2. So I have the absolute value of 2 minus 4 equals -2. So I have the point 2, -2. Let's plug in 0. You should always plug in whatever makes the absolute value that equals 0 because that's where the vertex or the corner of your graph would be. So the absolute value of 0 minus 4 is -4. So that will be where my corner is. So it should be easy to tell from here what the graph looks like. The absolute value of 3 minus 4 is going, negative 3. Is going to be still, regardless of whether you plug in 3 or negative 3, you still get the same y value. You're going to have negative 1. So the point 3, negative 1. So you should see here that it's just a V whose vertex has moved. The vertex moved down 4 because of that minus 4. So this is the easiest of the transformations to see. So if I just have the absolute value of x and I add some number to it, the graph shifts vertically that many units. So if I have f of x equals the absolute value of x minus 10, the graph's going to go down 10. If I change this from minus 10 to plus 3, the graph's going to go up 3. So now let's try to make it a little bit different. So here, the thing that I'm adding or subtracting is inside the absolute values. It's not on the outside. So let's see how this affects the graph. If you don't know what a graph looks like, you can always just plug in points and see what you get. So let's try to do that here. So here I have, let's try negative 3. If I plug in negative 3 into this, now that negative 3 plus 4 is on the inside of the absolute values. So negative 3 plus 4 is what I'm going to do first. That gives me 1. The absolute value of 1 is 1. So I have the point negative 3, 1. So now let's plug in negative 4. And negative 4 is what makes the inside of my absolute value equal to 0. That means that the vertex will be located at this point. So if I take the absolute value of negative 4 plus 4, I get 0. So now I know that the point negative 4, 0 is the vertex of my graph. If I plug in a number on the other side of this vertex, it'll help me get a good picture of what this graph looks like. Let's plug in negative 6, for example, because that's to the left of my vertex. So now if I do negative 6 plus 4, the absolute value of that answer, I get negative 2 on the inside of this absolute value. Once I take the absolute value, I get 2. So I would have the point negative 6, 2. If you're still not sure what that graph looks like, it's no big deal. Plug in another number. Let's try to plug in 0. 0 is always easy to plug in. If I take the absolute value of 0 plus 4, I get 4. So now I have the point 0, 4. So hopefully you're able to see that this is just a V graph that's just been moved over. So now the vertex of the original graph is at 0, 0. So now it has moved to the left 4. So this plus 4 is what did that. It kind of works in the opposite way as up and down. Plus 4 will move it to the left 4. Now let's try this one. Before we try this one, I have a little math joke for you. So what did the 0 say to the 8? Nice belt. Hopefully you guys like my poor attempt at a joke. Maybe you'll watch the rest of the video now. Alright, so now let's try to make this graph. So if I have the point, let's try anything. Let's try 5. I plug in 5, I get the absolute value of 5 minus 3 equals the absolute value of 2, which is just 2. So I have the point 5, 2. Oops. 5, 2. So now let's try another one. Let's try the point 0. If I plug in the point 0, I get negative 3 on the inside of my absolute value, but once I take the absolute value, I get 3. So I have the point 0, 3. So now let's always try to plug in the point that makes the inside of your absolute value 0. So we have to think, what would make that the inside of that 0? And that answer is 3. So if I plug in 3 into this, I get the absolute value of 3 minus 3, which is 0. So I have the point 3, 0. Now, hopefully you were able to predict correctly that this graph, this negative 3, is going to move the graph to the right 3. So here my vertex is just now going to not be at 0, 0 anymore. That minus 3 moved it 3 units to the right. So now that whole V just shifted over. So now let's look at the graphical transformation that's horizontal. So if I subtract or add something to the inside of my absolute value here, not on the outside, then it shifts the graph horizontally. So notice that there is a negative in this equation here. So it kind of behaves the opposite way as a vertical shift does. So let's try an example of this. So here, if I have that your function is the absolute value of x plus 2 minus 6, let's talk about what each of these do. So this minus 6 is the easier thing to try to think about. So that minus 6 will bring the graph down 6 units. Now let's think about what that plus 2 will do. Now you know that because it's on the inside of the absolute value graph, it does behave the opposite way than the sign says. So because it's plus 2, it's going to move in a negative direction 2, or to the left 2. So once you know that, you don't have to go ahead and bother plugging in points. You just know that my vertex is going to go to the left 2 and down 6. So over 2 and down 6. 1, 2, 3, 4, 5, 6. My vertex is going to be there. So you just draw your V at that location. So now let's try the next graph. I know that this order is a little bit different, but it's the same thing. This plus 8 is on the outside of the absolute values. So this plus 8 is going to move the vertex up 8 units. And take a second and try to think about what that minus 3 will do. Because it's on the inside of the absolute values, it's going to move the graph in a horizontal direction. Because it's minus, it will move it to the right 3 units. So don't bother plugging in points. Just start 0, 0, and go to the right 3 and up 8. And I know that my graph is going to start there. So then just draw your V there. Now we're not going to draw this last graph, but I just wanted you to kind of think about what would happen with this equation. So this minus 3/4 would move the graph to the right 3/4. And this minus 100 would move the graph down 100. We'll do some more practice with those tomorrow. Just one more quick thing before we're done our lesson. So how can we change the equation of the graph to make it look upside down like that? So the normal V faces upwards. So we're going to try to do something to the equation to make it flip and go downwards. So what we do for that is we're just going to put negative on the outside of that absolute value. So then it takes all the y values that it had and it changes their sign. So just to prove to you that this works, let's try to plug in 3 into this equation. I would have the negative on the outside and the absolute value of 3 on the inside. So the absolute value of 3 is 3. If I put a negative later, it's negative 3. Let's just check to make sure that this point is on our graph. If I go to the point 3, negative 3, that is a point on our equation, so it looks like we did this right. So please don't forget to answer the questions, and I'll see you guys tomorrow.